Okay, we're going to look at test tube tests in organic chemistry. So these are quick tests you can do, which will enable you to determine which functional groups are in a molecule. A lot of them are superseded really now by spectroscopy methods, but we need to know these ones anyway. Okay, so Fehling's test. Okay, this is a test for an aldehyde. Okay, only aldehydes, so you have the aldehyde functional group is that, of course. Okay, and how does it work? Is because aldehydes, well, they can be oxidized. They can be oxidized to carboxylic acids, and that means that if they can be oxidized, aldehydes are reducing agents. Okay, so Fehling's test is you have it's basically copper ions in a slightly alkaline solution, and that is a blue solution. And if you have an aldehyde, and only an aldehyde will do it, nothing else, the copper 2+ gets reduced to copper 1 oxide, which is a brick red precipitate. So that's the change there. That's what you're looking for. And you do need to heat it as well. So you usually put it in a water bath. And after that is finished, don't forget you will have some carboxylic acid in there. That's what you're going to have in there afterwards. That's the aldehyde will be oxidized. Right, there's a little bit of redundancy here. Tollen's test does exactly the same thing as Fehling's. It tests for aldehydes and aldehydes only. Okay, and again, it works because aldehydes can be oxidized. Aldehydes can be oxidized to carboxylic acid, so that means they are reducing agents, yeah? And what's the oxidizing agent we have in Tollen's? Well, it is silver ions. So, and usually that's, you get silver nitrate and you add ammonia to it because you need to have that slightly alkaline, ammoniacal silver nitrate. And the silver ion gets reduced to Ag metal. And if you do it correctly, the metal tends to stick to the surface of the tube and it forms a silver mirror. So that is Tollen's test, testing for aldehydes. Then we have this one, bromine water, which you've been doing this test in year 10. And of course, this is a test for an alkene, a carbon-carbon double bond. And what happens is, so you get a electrophilic addition across that to form the 1,2 dibromo thing, depending on what the alkene is. And so it's this is a brown solution, reddy brown solution, and it becomes decolorized. Don't say it goes clear. They want to say it decolorized. It's clear already. It's brown, but it's clear. You can see through it. Okay, so here's another one, the Dichromate test. Now this, so what happens here? This orange stuff we have got, it is potassium dichromate. And you also need to add some acid to that, H2SO4 usually. And you warm it up with your organic of choice. Right, now this, and it's an oxidizing agent, and it gets reduced to the Cr3+. So the question is, what can reduce the dichromate ion to Cr3+? Well, it's not particularly brilliant, this test, because it's a few things that will do it. First of all, it will oxidize a primary alcohol. It will also oxidize a secondary alcohol. It will also oxidize an aldehyde But I suppose you could use it to determine it will not work with a tertiary alcohol. You can't oxidize a tertiary alcohol. So that is a bit ambiguous information that would provide. They just tell you you've got either primary, secondary alcohol or an aldehyde there. Okay, next one. This is, so you add solid sodium carbonate, yeah, to your organic of interest. And if there is a carb, so it's a test for carboxylic acid. Test for that. And if you have a carboxylic acid there, CO2 is evolved, so it effervesces. And that's supposed to be little bubbles of CO2 in there. Okay, so sodium carbonate, that's what you can also use for that. You can use sodium hydrogen carbonate. It doesn't matter, both do the same thing. So if you've got an organic, it'll tell you you've got a carboxylic acid group in there. Okay, now this one really is not, it's not quite on the spec, but it's not really not on the spec either. And I have asked it a few times. Silver halide test. Well, you can use this for, if you're looking for haloalkanes. So let's just look at, say we have bromoethane, okay? If you have bromoethane and you add some OH minus to that, so you're going to add NaOH, what will happen is you'll form the alcohol, you get nucleophilic substitution, and you'll form the alcohol, and you will release the Br minus ion. And it is this, the test doesn't detect the alcohol, but it detects the release Br minus ion. Well, first of all, what you need to do, you need to neutralize with nitric acid, because if you don't, the OH minus and the Ag plus will form a precipitate of AgOH, which will confuse matters. And then what happens is the Ag plus ion and the Br minus ion will form silver bromide, which is a cream precipitate. Now it also works for the other halides. So if you did it with chloroalkane, you'll get so if you have RCl, you'll get a white precipitate. If you have a bromoalkane, you'll get that, the cream precipitate. And if you have an iodoalkane, you'll get a yellow precipitate. So what you do is you need to put your haloalkane in there, haloalkane with sodium hydroxide. And then first of all, you need to add nitric acid to neutralize. And then you need to add silver nitrate. Okay, so that's about all the test tube tests you really need to know for organic chemistry.